In this lecture, we'll look at SQL functions that work on values across multiple rows of a table. Now, the SQL aggregate functions are sum, AVG for average, max, min, and count. And MySQL adds a number more that are not SQL standard. All of these functions operate across multiple rows of a table, producing an aggregate result. For instance, say we wanted to find the highest price of all items in the product table of that Bakery2 database we've used before. I could write select max of price from product. There's no where clause, so this query retrieves all rows of product. But as you can see, it returns one result, the maximum value of price, across all those rows, $15.95 to be exact. Now, the other four functions work similarly, returning different aggregate values. So, for instance, we could do this query, and running it produces a single four-column row with values giving the minimum price, 79 cents, the average price, as you can see, the total of all prices, and a count of the number of prices. And again, these are across all rows of the product table. You can use the aggregate functions with a where clause to limit the rows to which they apply, if you like. For instance, perhaps we only want the minimum price for products that have chocolate flavor. And that would accomplish that. There's some special options on count and some special discussion needed. In its standard form, count simply counts the number of rows that are being summarized by the query. So its column argument is meaningless. Count of price or count of kind or flavor would all return the same value. For this reason, you may simply write count star, and indeed an often used idiom for just give me the number of rows in a given table is select count star from sample. So for instance, we could do select count star from product, and we'll get 40 here. And indeed, we could have replaced the count price with count star just as readily. So what if you want to know how many different prices there are in the product table, which may well be less than the number of rows in product if certain rows have the same price? All of the aggregate functions allow a distinct modifier on their parameter for this purpose. This has an effect similar to distinct in a select clause. It considers only one copy of each duplicate value. Now, the most useful application of this is with count. To get a count of distinct prices, we'd use what I'm showing here, select count distinct price from product. And as you can see, that returns 15, not 40. And if you're using distinct, then the column being counted matters, since different columns will have different duplicate values. So if I do select distinct or count distinct flavor from product, I get 24, not 15. The star notation is thus not allowed with distinct. And so here's question 1. The distinct modifier is rather less useful with other aggregate functions. What effect do you think it would have on the result of min or max, for instance? And what about average? Coming back from a pause, well, if you think about it, distinct has no effect on the outcome of a min or max call. As long as you have at least one copy of the least or greatest value being considered, the min or max is the same. The effect on average is subtler. One might, for instance, want an average price taken with each different price represented once, as opposed to averaging all the duplicates in, which would produce an average weighted toward the common prices if you included the duplicates. Now, you sometimes use aggregate functions to compute values across all rows of a table, like we've been doing. But most often, they are used hand in hand with the group by clause. As an example, let's generate a list of each different price in product, along with a count of the number of times that price is used, the number of products that have that price. This query would do that. Select price, count star from product, group by price. And as you can see, It produces a nice table with each price and a count of that price's number of occurrences, the number of products that have it. Group by thus does more than eliminate duplicates. It collapses or groups sets of rows into a single row based on what we'll call the grouping column. Though, as we'll see shortly, you may list multiple columns after group by, so we really should pluralize that to grouping columns. The group by groups all rows with the same value for the grouping column, call these the grouped rows, into a single aggregate row for that value of the grouping column. So, in our price example, the grouping column is price, and each set of grouped rows with the same price is collapsed or merged together into a single aggregate row. And the group by result has just 15 aggregate rows, one for each price, with each aggregate row derived from one or more original rows. Each aggregate row has a value for the grouping column, but it may also include the results of aggregate functions, like our count star, which are computed only on the rows that were grouped to make the aggregate row. That's the critical point. The aggregate functions are computed only on the rows that were grouped to make the aggregate row. So for each aggregate row in our price example, the count call considers only the grouped rows that formed the aggregate row in question, all those having a particular price. Each aggregate row has a different count result depending on how many original rows were grouped together to make it. The aggregate function calls in the select clause may work on any of the columns from the table, not just the grouping column, and you may include as many aggregate function calls as you like. So, if we want the minimum and maximum rating, let's say, per product ID from the rating table, recall that from earlier discussion, we could write select product ID, minimum of score, and maximum of score, group by product ID. This produces aggregate rows, one for each product ID, and computes the minimum and maximum score for the grouped rows for each product ID. The min and max will work on any sortable column, including strings. Count works on any column, period, and as we said, it's usually just past a star unless you're using distinct. Average and sum obviously require a column that has numerical meaning, but with SQL's proclivity for typecasting, this actually includes string columns, which one way or another can be converted to a number, even if it's 0. Here's question 2. Use a group by and an aggregate function to find the average price for each flavor of product, giving an output with 2 columns, the flavor, and the average price for that flavor. Coming back from a pause, which I would expect you ran your function to make sure it worked correctly, you should do your SQL statement. You should come up with this. Select flavor and average price from product, group by flavor. And there we are. Now, this would be even more useful if we could sort by average price. And in fact, we can use aggregate results for sorting, though, as it turns out, not for where clauses. We'll discuss an alternative to where clauses in the next segment. But we can at least write select flavor average price from product group by flavor, order by average price. And looks like walnut is the flavor to prefer if you're saving money. Now, you may also list multiple columns in the group by clause, as we saw when we first used it in earlier lectures. If you do, then each combination of values for the grouping columns gets its own aggregate row. For instance, if we want to check how many times each customer has rated each product in the ratings table, we might write select customer ID, product ID, and count star from rating, group by customer ID, product ID, and we'll group thus by both of those. And this will produce an aggregate row for each customer ID, product ID combination. And note also that each aggregate row has a value for both of the grouping columns, both of which are selected. Running it, as you can see, confirms that each customer has rated any one product at most once, as expected. That's part of the design of the rating table. Now, question 3. Let's shift to the Courses 2 database as given in the attached courses2.sql file. I've already loaded it, actually. Load it in for yourself as well, please, and then write a query that lists, for each department and each number of units, the number of courses offered by that department having that many units. Give the department ID, the number of units, and the count of courses with that many units. You should get 16 rows with counts of either 1 or 2. Coming back from a pause, I had select department ID, number of units, count star from course, group by department ID, and number of units both. And there we go. Now, here again, we're using several grouping column values. We'll have an aggregate row for each different department ID num units combination. And we're counting the number of grouped rows for each such aggregate row. In the next segment, we'll look at using group by with joins, and we'll introduce the having clause for filtering aggregate rows.